I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on mechanical energy and representing those with energy bar charts. Today we're going to talk about mechanical energy and how to represent mechanical energy using an energy bar chart. This is using the law of conservation of energy. But first of all, what is mechanical energy? Well, there are two forms of mechanical energy. It's associated with motion and the position of objects. So the two types are kinetic energy and potential energy. So let's look a little bit more into what these kinetic and potential energies mean. So kinetic, if we break that word down, kinetic is like kinematics we learned earlier, that means motion. So an object is moving if it has kinetic energy. If it's not, it does not have kinetic energy. Potential energy, there are two forms. Gravitational potential energy, which is associated based on positioning of height above a defined zero. And we also talked about in the last video, our spring potential energy. And that is with the configuration of a spring either being stretched or compressed. And the sum of these three types of energy is the total mechanical energy of a closed system. Closed system means that there's no external force adding or subtracting energy from that system. There are also non-forms of mechanical energy. Here's a couple examples. Thermal energy, which is heat. Radiant energy, which is energy we get from the sun. Chemical energy, so you have chemicals you combine together and a chemical reaction occurs that had stored chemical energy. And then sound energy, something you use every day where vocal cords vibrate, causing pressure waves to travel through the air to your eardrums. Now let's talk about work. So an energy transfer by an applied outside force is the definition of work. So what does that mean? Well, there's an energy transfer by a force, and that changes the mechanical energy of the system. So it's something from outside our system changing the amount of energy, either adding or subtracting energy in our system. And that increase or decrease applies directly to the kinetic energy. So what is this energy bar chart we've talked about? Well, it's used as a visual representation to represent the law of conservation of energy. It also shows objects that are working on the system by an energy transfer from outside the system in or inside the system out. And this is what a blank bar chart looks like. You have an initial situation. You have an energy flow diagram where you draw interactions much like a system schema in a free body diagram. And you have a final situation where you're going to represent the energies. And we'll talk about those types of energy. Step one in drawing energy bar charts is defining the system. How do you know what goes in the system? Well, only things that have mechanical energy. If it's not defined for you, here's what we do. We look for something that's moving and we put that in the system, car, ball, person, etc. So the car in this instance. Any elastic objects, such as a spring, a bungee cord, a rubber band goes in. Anything that can snap back to an equilibrium position, not like silly putty or Play-Doh that would stretch but not go back to an equilibrium. It just stretches and that's it. And then we're also going to include the earth in the system, and that accounts for us having gravitational potential energy. Any other object that we would have would go outside the system as work. So examples would be a person would go outside if they're pushing, or if their surface has friction, we put the surface outside the system as well. So objects that push or pull or anything that has friction. Step two, we're going to ask ourselves three questions for the initial situation. Is there an object moving? Well, if the object is moving, then we're going to have kinetic energy and we're going to draw a bar. And based on the heights of the bar, it doesn't matter. It's a qualitative representation of the bars. What matters is at the end when we compare them. The second is they're an elastic object stretched or compressed. If the answer is yes, then we're going to list US and then draw a bar, again, arbitrary for the height. It doesn't matter until we start drawing them each individual situation. Then you're going to ask yourself, do you have an object that is above or below the defined zero? Now, defined zero is when it's below is a very rare case. That would be an example if you define a desk as zero and there's an object on the floor. Most situations, you're going to define the lowest point in the problem as zero, and that is going to be zero, and anything above that is going to have positive gravitational potential energy. So if you have an object that is above zero, then you're going to label UG and then again draw a bar. So the answer to those three questions would tell you which bars to draw. Step 3, you're going to show energy flows. And here's a couple examples. So the arrows show the interaction between objects. So if a person pushes a car, a little lab cart, then you're going to draw an arrow from the person to the car because the person gave the car energy. If a car rolls up the ramp, it's going to slow down. Well, the kinetic energy has to be going somewhere. So the car is losing energy to the earth. So we draw an arrow from the car to the earth. Then another situation is if the surface has friction. If the car is rolling along, then we draw an arrow from the car to the surface because friction is going to cause the car to slow down. Now, this is just a couple examples. There are many interactions. The car could interact with the spring and the spring with the person. Lots of different interactions. You just have to draw the arrows. Step 4, you're going to ask the same 3 questions. Is there any object moving in the final situation? If yes, draw kinetic. Is there an object that is stretched or compressed that's elastic? If yes, you're going to draw US and draw a bar underneath there. And then finally, is there an object that has a height above or below defined 0? If yes, you're going to draw UG. And again, rare if it's below, you'd have to draw a negative amount. And then step 5, the whole point of drawing our energy bar chart is writing the conservation of energy equation. So the conservation of energy equation comes from the bar chart. And here is a conservation equation you can write every single time. Remember, the total mechanical energy is the sum of kinetic and potential. So initial kinetic plus the spring initial plus gravitational initial plus or minus work is going to equal the final kinetic plus the stored spring energy in the final plus gravitational in the final. And this is what you're going to write each time and then just cross out what you do not need. So this is the basics to energy bar chart and introduction to mechanical energy. I hope this was helpful. I hope you have a great day and an even better tomorrow.
If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.